Today I want to talk about something called the determinant. And the determinant is a real number that is associated with a square matrix that can be used to find the inverse of the matrix. So the whole purpose of this is simply for us to find a number that we are going to use later on when we find the inverse of a matrix. So don't be too worried just yet about what the inverse of a matrix looks like. This is just going to be a necessary skill for us to learn to be able to find that inverse of that matrix later on. So the determinant is simply this real number. Now, I want to start by talking about something called the diagonals method. And this is incredibly easy. The only problem is that it's just limited. It's only can be used for 2 by 2 and 3 by 3 matrices. But if most of the matrices we're going to be working with in this course are that, then this is actually a pretty simple strategy for us to employ. So the diagonals method is simply the following. It just says, and I'm going to be using a lot of colors here in this lesson today, it means that we are going to multiply the diagonals and we are going to subtract their products. So in this case, we would go ahead and we would multiply A times D, find that product, and then multiply C times B or B times C, and then just subtract those two. And the notation that we use for the determinant, it looks a lot like the absolute value. So it looks like these bars that are around the A there. So let's practice finding the determinant of this 2 by 2 matrix. So again, the first thing I'm going to do is I'm going to go ahead and multiply 2 by 5. So we're going to say 2 by 5. And then we're going to multiply the other diagonal, 3 times negative 1, or 1 times negative 3. And it's important to note that we are going to be subtracting these products. So we're saying minus 3 times negative 1. Okay? And this would just say, so we can then say that the determinant of this 2 by 2 matrix is the result of taking 10 minus negative 3, right? Which is just 10 minus negative 3. So our determinant here is 13. Okay? Go ahead and try to find the determinant of number 2 on your own. Well, hopefully you've had a chance to do that. So now let's look at how we would do the diagonals method for 3 by 3 matrix here. And for this, it's going to be a little bit more work because there's a bit more going on, mainly because I can't draw the diagonals or identify all my diagonals. I can certainly do something like this. I can say AEI, right? I can write something like, okay, I'm going to multiply A times E times I, but where would my other diagonals be? Like, how would I be able to draw something or highlight something like this, for example? Well, what we're going to need to do is we are going to need to transpose or take the first two columns of our matrix and rewrite them to the outside so that we can complete our diagonals. That is to say, I'm going to need to write A, D, and G. Let me just actually zoom in here so we can see this a little bit more clearly. So A, D, G. I'm going to basically take that first column and rewrite that over there. Then I'm going to take B, E, and H. And what this does is this allows me to finish my three diagonals. So what I'm going to do is I'm going to write the following. I'm going to say, all right, I'm going to find A, E, I, then let's just rewrite the rest, plus B, F, G, plus C, D, H. Okay, so I've got those three diagonals, and I'm going to find the product of each one of those diagonals. Now, what about the other way? So what I'm going to now need to do is I'm going to then find these diagonals here. So go ahead and write GEC. Now, just like the method that we did above, we were subtracting these diagonal products. So we're going to need to do the same here. And an easy way for us just to keep track of the fact that we're subtracting here is just to write kind of like this negative sign here above that C, just to indicate that I'm going to be subtracting this. So I'm going to say minus GEC. Then, and I'll just keep this all in the same color, HFA and IDB. And again, I'm subtracting these. So if I write that out, let me actually just move this here since I think I should have enough space. Minus HFA minus IDB. So we're going to multiply down from top to bottom, left to right, and we're going to multiply and find those three products, and then we're going to subtract the products of the diagonals going in the other direction. So let's try an example of this. So here, I'm not going to write out every single number, but let's just start by rewriting the first two columns on the outside. So I'm going to write 3, 3, -1. That was that first column that I'm rewriting over there. Then 4, 5, 4, which is that second column there. Now I'm ready to do my diagonals. So let's start with, and I'm just going to do this in red, these three diagonals here. So I'm going to find those three products. So let's start with 3 times 5 times 1. So we can just say that the determinant of this matrix is going to be 3 times 5 times 1, which is 15. 4 times 0 times -1, which is 0. And in the third diagonal, -2 times 3 times 4, that's -24. Okay? So I'm just going to go ahead and highlight these in red to show that those were the results of those products. Now let's go the other way. So now I'm going to highlight these diagonals, and I'm going to write those results. So I almost wrote positive. So remember, this is probably a good reason why I do this, just to remind myself that I'm subtracting now. So minus -1 times 5 times -2, which is positive 10, but I'm subtracting it. So I'm going to write minus 10. 4 times 0 times 3, which is very easily just 0, so minus 0. And then 1 times 3 times 4, which is 12, but again, I'm subtracting. So again, these were the three products that I had. I'm subtracting these three products here. Well, the result of all that, well, that should give me -9, -19, and that should be -31. So there is my determinant. Again, right now we don't have too much of a sense of what this determinant is. All we know is that it's going to be useful when we are finding the inverse of the matrix later on. Now, what happens when we're dealing with a matrix that is larger than a 3 by 3? The diagonals method is nice. It's actually pretty quick once you get the hang of it. But what about when we're dealing with 4 by 4s or 5 by 5s? Well, the obvious answer is we'll probably use a calculator then. But just so you know how we might actually approach something like that, it's called the expansion by cofactors method. And this is, again, used for something that is a 3 by 3 or higher. And it looks kind of complicated at first, but I promise you, once you get the hang of it, similarly, it's actually not too bad. So what we're going to do is we're going to find what's called the minor of each row or column, and then multiply them by the corresponding entries in that row or column. So here's what I mean by this. So take a look at this matrix A here, all right? And to find the determinant of this matrix, here's what I'm going to do. And let me switch to a different color. So with this green pen here, just kind of watch what's happening here. If I start with this first entry, I'm going to start with this entry A. And you won't have to start there in future problems, but I'm going to do that since it's the most obvious one right now. If I'm starting with my entry A, what I'm going to do is I'm going to remove or temporarily ignore its corresponding row and column. So just kind of cross those out, at least mentally. And what you have left over is its own little mini 2 by 2 matrix here, right? So what you're going to do is you're going to find the determinant of this matrix, this leftover EFHI matrix. So we're going to find the determinant of this matrix. And again, the notation, when you have these bars, not these brackets, but these bars around a matrix here, that's to indicate that we're going to be finding the determinant of this. So we're going to find the determinant of this matrix. That determinant is called the minor of this matrix A. So it's we would say this is the minor of A. So let me write that. This is the minor of A, or minor of A sub 1, 1, which was the entry in the first row of that first column. Okay, let me go ahead and use a different color to indicate our next minor. Then we're going to move on to B. Well, we're going to go along this row, which means we're going to cross out the rest of the entries in that row, and we're going to cross out its column. Now, what's left over? We're left with a matrix that is D, F, G, I. So you then find the minor of that, or the determinant of that matrix, which is called the minor of B, or the minor of A sub 1, 2. Now you'll notice here that I'm alternating the signs. This is going to be a minus here, right? So we're going to be subtracting that. Now, for the final one, let me just do a different color for this as well. If I then move on to the final entry in that row, so entry C, or entry 1, 3, I'm going to cross out its row. I'm going to cross out its column. What's left over? D, E, G, H. So this would be the determinant of this matrix would be m sub 1, 3, the minor of C. And a cofactor is simply these determinants, or these minors, I should say, with the sign, with the corresponding sign that is associated with it. Okay, and I try to kind of visually show you what was happening here. And remember, every single time we're finding the determinant of a 2 by 2, we can just employ the diagonals method. Now, key thing here, a couple key things. Number one, I did not have to use row 1, right? So I went along here and I did row 1, but you don't have to use row 1. But that's sort of what's neat about this, is that you can use any row or any column. So I could have used this column here, for example, BEH, if I wanted to. And I'll show you in a moment how you can actually do that. But as you go along, you just have to really remember that you are eliminating the row and the column for each one of those entries. Now, why would you want to choose a different row or column other than the first one? Since we're doing some multiplying, often it's beneficial to choose the row, and let me write this. It's beneficial to choose the row or the column that has the most zeros, because it's just going to make your life easier when you're doing calculations, right? So anytime you're multiplying by a 0, the result is just 0. So oftentimes you want to choose the row or column that has the most zeros. Also, pay attention to the fact that I subtracted that b value here, and we want to make sure that we have alternating signs. This is effectively us working with a different application of the diagonals method. So something that I kind of draw out for students is to remember that we have a positive, negative, positive, and in the next row, we want to alternate the signs always. So your signs are going to look something like this, depending on which row or column that you choose. Well, what if we wanted to do a 4 by 4 matrix? What would those signs look like? Again, we're just alternating. So for a 4 by 4, I can expand this out, make this negative, make this positive, negative, negative, positive, negative, positive. So just remember that the signs alternate, and that's going to be helpful when you are using the expansion of a different row or a different column, and just something to pay attention to. And like many things in math, I think it's probably most helpful at this point if we just go ahead and do a problem so you can kind of see it done from start to finish. So let's try this example here. Let's take a look at this, the determinant of this matrix. So it's a 3 by 3. We already know what the determinant is. We did this in the previous problem using the diagonals method. But let's try the cofactor method, the expansion by cofactor method, to see if we can get the same result. Now, I'm going to just go start with the first row, since that's kind of how we were introduced to this method, using the first row earlier. But in a moment, I'll show you how we might be able to do this if we use a different column or a different row. So we're going to start first off with, and again, let me just try to keep track of this with colors. Let's start with this entry here in this row. So again, I'm going to cross out its corresponding row and cross out its corresponding column. So what we're going to say here is we're going to do 3 times the determinant of my remaining matrix, which is 5, 0, 4, 1. And we'll do all the math with this in just a moment, but let's just set this up first. So, well, actually, might as well, since we're already using the color red. So we've got 3 times. Now, what is the determinant of this little mini matrix here, or what we say the minor of 3? Well, that would just be 5 minus 0. So that's just 5. So we can say so far we've got 15. All right, and we'll just keep track of this as we go along. Now let's try the next entry. Switch the color. Now again, remember that we are subtracting here. So we're going to say minus. And so we're doing this next entry. So we're going to cross out this row and cross out this column. So minus 4. And then from here, what's the remaining matrix? We've got 3, 0, negative 1, and 1. So let's find that minor. So the minor of 4 would be 3 times, or I should say 3, minus negative 1. Well, 3 minus 0, I apologize. 0 times negative 1 is clearly 0. So 3 minus 0, that's just going to give me 3. So I'm going to write minus 12 underneath. All right, now just to wrap this up, let's try the next one. We're going to go this entry here, negative 2, the last entry of that row. So we're adding a negative 2. So we're adding a negative 2. Cross out its column and row, and we're going to find the determinant of 3, 5, -1, and 4. So this is just going to be minus 2 times the determinant of this matrix, which is 12, 12 minus -5. So 12 minus -5, this is going to be positive 17. So this is minus 34. So what do we have here? And I'll just write this out. We can say that the determinant of this matrix A is going to be 15 minus 12, which is 3, minus 34, that's -31. And that's exactly what we got previously in our problem here using the diagonals method. Now, clearly the diagonals method was probably a lot more time efficient, but on that note of time efficiency, I said earlier that you can choose a row or column with the most zeros to speed this up a little bit. So for example, had I done this maybe using the third column, let me model how we might do this using a column that has zeros in there. So really quickly, so first off, if I want to use the third column here, I'm going to do this a little bit more quickly. Let me write this by the third column. Okay, so I'm going to start with -2. And again, I'm not going to cross everything out. Hopefully you're starting to see how this works. -2 times 3, 5, -1, 4, so that matrix. And then here, notice that this one is going to be negative, right? Because remember the signs, this goes positive, negative, positive. Now, from here, I notice, and before I even set this up, I know that I'm going to be doing 0 times something, blah, 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 blah. That's a little insulting to say blah, 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 blah. But the whole point is I know I'm going to be multiplying 0 by something, so I don't really care about that. I can just say -0. I know the result is going to be 0 because anything times 0 is 0. So then I can just move on to the last one, plus 1 times the determinant of 3, 4, 3, 5. So if I set this all up, let's finish this up. We got -2 times 12 minus -5. Well, that's going to be 17, plus 1 times, anything times 1 is just itself, so 15 minus 12, that's 3. So this also gives me -31. And just a little bit faster since you're dealing with one value that you already know is going to be 0. Now, the last thing I want to just highlight here is whenever you have a triangular matrix, that is a matrix that is in REF, a row echelon form, one little neat trick is that you can just go ahead and multiply by the main diagonal. And maybe pause and think about for a second, why do you think that would be the case? Why do you think we can just simply multiply by the main diagonal to get this? And if you've been following this method of expansion by cofactors, hopefully it sticks out to you. But what's the nice little shortcut to this is you can just multiply to find the determinant of this matrix. It would simply be 2 times 4 times -1 times 6, which would be -48. So this will take a little bit of practice just to get the hang of it, but I promise you once you do get the hang of it, it goes a little bit faster than what I've shown here. And hopefully now you have a good sense of how to find the determinant of a matrix using a couple of different methods.